Good evening, students. Welcome to APJ Academy. So today we are going to discuss about the new topic from the new chapter, that is atomic structure. Okay. So hope the previous classes were clear for you and all the concepts are clear for you. If yes, then we can start the new session. So let me check with the streaming whether it's clear or not. Only I can see your yes. Yeah. Okay. Now let's start with the topic. Today we are going to discuss about the Bohr atomic model. So in atomic structure there are different atomic models we study. There are quantum mechanical model is there, Bohr model is there, Thomson's model is there, Rutherford model is there. So among all these, Bohr model and quantum mechanical model is the most important one. Okay, and Bohr is the scientist who have contributed a lot with regards to the atomic model, regarding the orbits, regarding the stability of atom. Everything was explained by Bohr. Okay, so now let's get started. Hope your preparations are going well. Now we are on the verge of nearing towards your JEE exams, right? So I wish all the students who are appearing for JEE exam all the best. Okay, with full confidence you write the exam, you will surely get good marks. So don't get panic or don't get tensed. Okay, with full confidence go out and rock it. Okay, now here students, here is an ad of our course, that is full year course. So we have provided all the important or necessary aspects which will help you to understand what all are present in our course. Okay, you can go through the slide and you can just read what all features have been providing in this 1 year course. Okay students, and now here is the discount. This is an enormous discount that we are providing the whole course for just 490 rupees per month. Okay, so you have to go through the course, you see our classes, you watch our YouTube classes, and if you feel that this is worth going for, then we are ready to help you out. You are always welcome. Okay, yes. Now let's move on to the next slide. And if you are watching this for the first time, just remember this: we are providing free classes regularly in our YouTube channel. Okay, and also for NEET aspirants as well as for JEE aspirants, we have two channels. One is for NEET as well as for JEE. And if you are a NEET aspirant, then you can subscribe to this channel. If you are a JEE aspirant, you can subscribe to our JEE channel, right? Okay, so this channel will surely add value to your preparation, that's no doubt. Okay, now this is all about me. You can just read through this, what I am, who I am, what all experience I had, how many students I have guided, all these things you can just read it in the screen. Now let's start with the topic Bohr atomic model. First of all, you have to understand, we know that atom is the basic unit of matter. Atom is the basic or the fundamental unit of matter. And in that atom, we have already discussed in some basic concepts that in atom, there are three subatomic particles where there is a nucleus in the center, where there are protons and neutrons present in the nucleus, and electrons are revolving around it. Okay. Now, Bohr has explained, or Bohr has given a proper explanation or description regarding atom. We cannot say that what Bohr said is 100% correct. We can say that most of the things which Bohr had told about an atom is correct. There are certain things which Bohr couldn't consider. For example, we know that the electron have dual nature, right? They have particle nature because they act as a particle with a certain amount of mass, and they also have wave nature because they move like wave. But Bohr only considered electrons as a particle. Not, he didn't consider the electron, or the wave nature of electron was not considered by Bohr. So obviously there will be certain limitations from the we can see from the Bohr atomic model. Since the electrons show both the nature, that is the wave nature is shown by electron as well as the particle nature is shown by electron, but Bohr only considered what? He only considered the particle nature of electron. So the very first point I want to tell you is that Bohr model is applicable only for those species or those atoms or those ions which consist of only one electron. Okay, so one electron species, Bohr model is applicable only for those one electron species. Like we know that if you are considering an atom, there is only one atom, there is only one element which has one electron, that is hydrogen. All the other elements have more than one electron. So if you are considering the other atoms or the other elements, then we have to consider the ionic state. That means, for example, helium. We know that helium consists of 2 electrons, but Bohr model is only applicable for helium plus ion, because helium plus consists of only 1 electron. Okay, likewise lithium 2 plus, beryllium 3 plus, likewise it goes. So 2 important points I want to discuss. One is Bohr model is only applicable for one electron species. The second point is Bohr model is based on particle nature of electron. So hope these 2 points are clear for you. Yes. Now we'll move on to the next one. Let's see here. Oh, let me just clear this. Okay. Yeah. Let's see here. Electron, we know that now we are going to discuss about the important postulates of Bohr model. See, the very first important postulate that Bohr told about his atomic model is that electron revolves around the nucleus in a circular path. Okay, he told that yes, nucleus is present in the center and electron is revolving around the nucleus in a circular path, and that for that path through which the electron revolves, he named it as orbit. Okay, he called it as orbit. And he told that electron can only revolve in those orbits which have angular momentum, which is the angular momentum equal to the integral multiple of h by 2 pi. What does that mean? See, we know that this is an atom. Here we have a central nucleus. Okay, we know that electron is revolving around the atom, so let's consider this as an electron. Okay, so what Bohr said is that electron can only revolve around those orbits whose angular momentum, what do you mean by angular momentum? Linear momentum into radius. Linear momentum is mass into velocity into radius will give you angular momentum, and this angular momentum should be an integral multiple of h by 2 pi. What does that mean? Integral multiple means it should be a whole number or an integer of h by 2 pi. That means if you consider an atom, there are infinite number of orbits will be present, but the electron occupies only those orbits which are of the value 1h by 2 pi, 2h by 2 pi, 3h by 2 pi, 4h by 2 pi, 5h by 2 pi. This is what Bohr said. Okay, he said that there cannot exist an electron in an orbit whose angular momentum is of 1.5 h by 2 pi, 2.3 h by 2 pi, 4.5 h by 2 pi. That is not possible. He told that it should be integral multiple. That means it should be h by 2 pi. H by 2 pi is a constant value. H is Planck's constant, and 2 pi, we know that 2 pi is another constant. So it's a constant value. Okay. Hi Aniket Kumar. It's a constant value, but it should be the integral multiple of that constant value. So there are numerous orbits around the nucleus, but electron only occupy those orbits which has an angular momentum which is an integral multiple of h by 2 pi. Hope that is clear for you. Now let's see here, MVR is equal to, I told you it is equal to nh by 2 pi, where n is equal to an integer, a positive integer, 1, 2, 3, etc. And h by 2 pi, I told you h is Planck's constant and 2 pi is another constant. You can, if a constant divided by another constant means a new constant, that can be represented as h bar. Okay, instead of h by 2 pi, you can use the term h bar. So I can rewrite the formula as MVR is equal to n into h bar, whereas h bar is equal to h by 2 pi. We know that where n is equal to, I have already told it should be a positive integer number, that is 1, 2, 3, etc. So the electron only revolves around those orbit which has an angular momentum of h by 2 pi, 2h by 2 pi, 3h by 2 pi, 4h by 2 pi, 5h by 2 pi, like that it goes. Hope this is clear, students. And here I want to discuss to you about one of the limitation of Bohr model. One of the limitation of Bohr model is that, see, he has taken the constant as h by 2 pi, but Bohr has failed to explain why he took h by 2 pi. See, h by 2 pi, he told that the electron can only revolve in those orbit, or electron can only be present in those orbit whose angular momentum is h by 2 pi. But from where he got this h by 2 pi, that he couldn't explain. So that was one of the drawback of Bohr model. Okay, now let's move on to the next one. So here, what I have told you just before is mentioned over here. That is, if n is equal to 1, then we get the value, the angular momentum of the orbit will be h by 2 pi. If n equal to 2, then it will be 2h by 2 pi. If n equal to 3, it will be 3h by 2 pi. Okay. So I also have told you that n cannot have any fractional value like 1.5h by 2 pi or 0.5h by 2 pi. Such fractional values are not possible for n. Bohr told that electrons only occupies that orbit with an angular momentum which is integral multiple. It should be integer multiple of h by 2 pi. That can be integer. N should be an integer. It can be 1, can be 2, it can be 3, etc. But it should not be any fraction. Okay. Now let's move on to the next point. The orbits in which electron revolve, can revolve are known as stationary orbits, because in these orbits energy of electron is always constant, and these orbits are numbered as 1, 2, 3, 4, etc. or KLMNO, etc. from the nucleus outwards. See, this is another important point, because from Thomson's model we upgraded to Rutherford model. Rutherford model, there was a problem that he couldn't explain the stability of atom. According to Maxwell's theory, if electron revolves around the nucleus, that means if electron is revolving, it is utilizing its energy to revolve. As it utilizes its energy, there is a point where electron loses all of its energy, and its energy can become equal to 0. If that happens, then the electron will fall into the nucleus. You got the point? Here, this is the atom, this is the nucleus, and we know that the electron is revolving. Okay, electron is revolving. As it moves, we know that electron occupies certain velocity. If it has velocity, then obviously there will be kinetic energy, and it moves with certain kinetic energy, and as it moves, as it revolves, it loses energy, keeps on losing, because it is utilizing its energy in the form of kinetic energy. So there will be a point when the electron's energy will become equal to 0. And if that happens, what will take place? If that happens, then the velocity becomes 0 and the electron will fall into the nucleus. If electron falls into the nucleus, then that atom get destroyed. If that happens, then think about the universe, think about our body, think about everything around you. Everything will get completely destroyed. No earth, no universe can exist if that happens. Okay, so we are seeing that even though electrons is revolving in its orbits, there is not even a fraction of energy is released by electron, or there is no fraction of energy is utilized by electron, and this criteria is not happening, or this phenomenon is not taking place in any of the atom. Atom is not getting destroyed, but the electrons just keep on moving. So here the Rutherford failed to explain the stability of atom, but Bohr explained it very well by calling that orbits as stationary orbit. What does that mean? Bohr told that if an electron is placed in a stationary orbit or an orbit of constant energy, the electron need not have to use its energy, but each shell or each orbit is having energy field. Okay, they have certain energy field, or we can call it as a constant energy field. And when an electron is placed in a constant energy field, because of the presence of this energy field, the electron moves. That means electron is not utilizing any of its energy. It is because of the energy field present in this orbit is pushing the electron to revolve around it. So is there any case of energy loss of energy for electron? No. Is that clear, students? So I can relate this to the slide, or the slide that you see in the water theme park. In the water theme park, you know that there is a curved slide. Okay, you enter it from by the means of a stairs into the slide, and you go on through the slide and reaches to a pool, right? So what is happening there? Are you utilizing your energy to move? Actually, no. What is pushing you? The very one thing is that we know that inside the slide the water is gushing with certain velocity, and that water, or the energy of that water, is pushing you through the slide. And because of that, you moves with the slide, or moves with along the slide, and you reaches the pool. You haven't utilized any of your energy. This is what actually happens with the electron. When an electron is occupying an orbit, and that orbit is a constant energy field, and because of this presence of this energy, the electron starts to revolve, because of which the electron need not have to utilize its energy. So the atom remains stable, and the condition which I explained before, that there will be a point where electron loses all its energy and it falls into the nucleus, that never happened. So this is where Bohr has explained the stability of atom. Hope that is clear, students. This is a very important point. Okay, now you have to also understand how the electron is revolving. So without changing its path, that's what you have to understand. See, here we know that there is an attractive force between electron and nucleus. This attractive force is called as the electrostatic force. Similarly, if you are moving in a circular orbit, there will be a force which pulls you outwards from the orbit or from the circular path, which is called as the centripetal force or centrifugal force. Anyway, a centripetal force, right, or centrifugal. Okay, let me check that. Yeah. Yeah, it's centrifugal force. Okay, centrifugal force. So see that you also have experienced centrifugal force. I'll tell you. Have you traveled in a bus? So I think you have. If you haven't, you have to. or you might have traveled in a car. So in a curved path, when the car or the bus moves in the curved path, as it moves along the curved path, you will experience a force that pushes you towards the opposite side of the curve. So if the bus is moving this way, you will experience a force in this direction and you will move away from the curve, and that particular force is called as the centrifugal force. So electron experiences the centrifugal force, at the same time the electron experiences the nuclear attraction. So these two forces are equal and opposite. That's why the electron always placed or always follow the same orbital path. If what is centrifugal force? We know that it is mv square by r. Centrifugal force is equal to mv square by r. So if the velocity becomes equal to 0, that means the centrifugal force will be 0. So there will be only what? There will be only the nuclear attraction. So the electron can easily fall into the nucleus. But this doesn't happen since the velocity cannot be equal to 0, since it is not utilizing any of its energy. Okay. So hope that concept is clear. Now we will move on to the next one. Okay. Now let's see here. So here you can see that the value of n, if the value of n is equal to 1, that is the ground state. What does that mean? I'll explain here. See, we have a nucleus. From the nucleus, this is the first orbit, or we call it as the first shell. This will be the second shell. This will be the third shell. And likewise, we normally consider 7 shells. Okay, because in a periodic table there are 7 periods. So here, what does that 7 period represent? 7 period represents the 7 shells in an atom. Okay, so this is the first shell. This is the first shell. How did I call it a first shell? Because it is the most nearest shell to from the nucleus. Okay, so first shell means it is the nearest shell from the nucleus. The second nearest is the second shell. Third nearest is the third shell. Fourth nearest is the fourth shell. Likewise it goes. Okay, so this is the first shell. This is second. This is third. This is fourth. Then we have fifth shell like this. This is the fifth shell. Likewise it goes. So if n equal to 1 means that is representing the first shell, and first shell can also be called as the ground state, or you can also represent it as the K shell. It can also be called as K shell, or we can represent them as the ground state. And if an electron is present in the second shell, then we call it as the first excited state. First excited state. And if the electron is present in the third shell, then we call it as the second excited state. And for the electron present in the fourth shell, we call it as the third excited state. What do you mean by excited state actually? See, I have already told that Bohr discusses, or Bohr model is only applicable for those species which have one electron in them. So let's see, if I have one electron, let me draw the shell like this horizontally. Okay. So this is the electron I have. This is the second shell. This is the third shell. This is the fourth shell. Likewise it goes. So the very basic thing you have to understand here is that if the electron is present in the first shell, that means it is very close to nucleus. That means that electron is very stable and it has less energy. You have to keep this point important in your mind, that if the electron is closer to nucleus, then that electron is more stable and it has the least energy. So if an electron wants to move to the second shell, what it should do? It should absorb certain energy, then only he can move to the upper shell, because in the lower shell the energy is low. So in order to move to the higher shell, it required to absorb certain energy and it have to move. Okay. So that's why we call the first shell or the second shell as the excited state. The ground state, this is the ground state. I'll represent it as GS. ground state. This is the first excited state. Next is the second excited state. Then the third excited state. Likewise, it goes. So the electron in the first shell absorbs energy and get excited to the second shell. It can again absorb certain energy and it can again move to the third shell. Then it can move to the fourth shell. Then it can move to the fifth shell. So each transition, electron have to absorb energy. Similarly, if the electron in the last shell wanted to come back to the first shell, what does it do? It has to, if it wants to come back, then it has to release that much of energy which it has absorbed to reach to this last shell. Okay, why it has to release? Because in the first shell the energy is very low. So an electron having higher energy cannot come to the lower shell. It has to release that energy and have to be in the same energy state as that of the first shell, then only it can jump back to the first shell. So here the point is very clear. The emission or absorption of energy in the form of photon can only occur when electron jumps from one stationary state to another. So electron absorbs or releases energy only when it jumps or it comes back from one energy shell or from one energy state to next energy state. Okay, that means we know that there is an energy difference between first shell and second shell. Obviously, first shell will have lower energy, second shell will have higher energy, and we can represent that energy gap as delta E. That is the difference in energy between first shell and second shell. So delta E means delta E is equal to energy of the higher shell minus energy of the lower shell. That means energy of N2 is the higher shell, and energy of N1. That will always be positive because we know that energy of the first shell is the minimum energy. Energy of the higher shell will be greater than that of the first shell. So in order for an electron from the lowest or the ground state to go to the higher energy state, it have to absorb energy. For an electron to come back to the lower state, it have to release energy. How much energy it should release? It should release an energy equal to delta E. What does that delta E? Delta E is the energy of the higher shell minus energy of the lower shell. Clear? If an electron want to jump from third shell to second shell, how much energy it should release? It should release an energy of E3 minus E2. This much energy it should release in order to come back to the second shell from the third shell. Hope this is clear, students. Now let's move on to the next one. Now this is what we have just explained. Energy is absorbed when electron jumps from inner to outer orbit. From inner means the orbit which is closer to nucleus. Okay, outer means the orbit which is away from the nucleus. So when it jumps from inner to outer orbit, it have to absorb energy. When it comes back to the inner orbit from outer orbit, when it comes back to the inner orbit, the electron will release energy. That is, energy is emitted when electron moves from outer to inner orbit. Okay, yes. Now let's see this. Okay, now we are moving to the next important topic, that is applications of Bohr model. Here you can see that, dear students, the very first application of Bohr model is the radius of various orbits. The Bohr has also provided us with the important formulas in order to find out the radius of the orbits. So what do you mean by radius? First of all, let's check this out. If you consider an atom, okay, I have a nucleus and this is the shell, and from the center of the nucleus to the shell, that indicates the radius of that particular orbit. If I am considering another orbit like this, it's not the perfect circle, but even then an arbitrary circle. Okay, from the center of the nucleus, the distance towards that orbit will give you the radius of that particular orbit. So in order to find out the orbit, Bohr has given us this equation, that is radius is equal to n square. What do you mean by n? N means the number of the shell or the number of the orbit, whether it's a first orbit, second orbit, third orbit, like that, into h square. H means the Planck's constant, divided by 4 pi square into mass. K is the electrostatic constant, that is 9 into 10 raised to minus 9 coulomb. Z is the atomic number, and E square means E represents the charge of an electron, that is equal to 1.6 into 10 raised to minus 19 coulomb. Okay, here K is equal to 9 into 10 raised to 9. These are the constants. And E, we know that the charge of electron is 1.6 into 10 raised to minus 19 coulomb. And H is equal to the Planck's constant, which is 6.63 into 10 raised to minus 31. Likewise, after giving all the values of the constants, that pi is equal to 3.14, after applying all the values, we got the equation, the reduced form of equation, that is R is equal to 0.529 n square by Z Armstrong. N square by Z Armstrong. Okay, so this I have given here in the box. Now you can say that R is directly proportional to n square by Z. This is a very important relation. R is directly proportional to n square by Z. Okay, so how did you calculate the radius? See, we do not require any derivation, but even then I can explain you the concept that I have already told you. There is an electrostatic force of attraction between the nucleus and electron. So that is directed towards the nucleus. And there will be a centrifugal force which pushes the electron to the away from the nucleus, right? So these centrifugal force and electrostatic force of attraction are both equal and opposite. And we equate both and we find out the value of R. That's how we got the value of R. And R is equal to 0.529 n square by Z Armstrong. Armstrong is a unit. That means 1 Armstrong is equal to 10 raised to minus 10 meter or 10 raised to minus 8 centimeter. So this is also you have to remember. Okay. Now let's move on to the next one. Here we are going to calculate the velocity of an electron. See, for velocity of an electron also we have Bohr has provided the equation that velocity of an electron in an orbit is equal to 2 pi k z e square by nh. From this equation we know that pi is a constant, k is constant, electrostatic constant, z is another constant, it is atomic number. So but we will consider z because for each atom z varies, right? E is constant, 1.6 into 10 raised to minus 19. H is Planck's constant. So after applying all the values of this constant, we got the value of V as V equal to 2.18 into 10 raised to 6 Z by N meter per second. So this formula you have to by heart it. Okay. Now the important relation we obtain here is velocity is directly proportional to atomic number by number of orbits. As the atomic number increases, what do you mean by atomic number? Atomic number is the number of protons or number of electrons. Here let us consider it as the number of proton. If the number of proton increases, that means the positive charge in the nucleus increases. That means the force of attraction between the nucleus and electron increases. As the force of attraction increases, velocity increases. That's the reason why as Z increases, velocity increases. And as the n value increases, velocity decreases. What does that mean? N represents the orbit in which electron is present. As the n value increases means the electron is moving away from the nucleus. As the electron moves away from the nucleus, its velocity decreases since the attraction between the nucleus and the electron decreases, the velocity also decreases. So this is another important relation. Previously we had a relation of radius. Radius is directly proportional to n square by z. We know that as the number of shell increases, the radius increases. That means the distance from nucleus, center of the nucleus to the shell increases as the n value increases, right? So this you have to remember. R proportional to n square by z and V proportional to z by n. Now another one. Here we are going to discuss about the time period. Okay. Now regarding the time period, what do you mean by time period? See, let me consider an orbit here. This is an orbit. We have a central nucleus. We know that the electron is revolving around the nucleus. So here I'll give you the electron. This is the electron. So this electron is revolving in this direction. So when the electron starts moving along the orbit and it reaches to the initial point, we call it as one revolution. So what do you mean by one revolution? When an electron starts from a particular point and it reaches the same point, then we call it as one revolution. So what do you mean by time period? Time period is the time taken to complete one revolution. Okay, time period is the time taken by the electron to complete one revolution is called as time period. So time period is equal to distance by velocity. Time period is equal to distance by velocity. We know that speed equal to distance by time. So time is equal to distance by speed. So what do you mean by the distance? Distance is the circumference of the orbit, right? Distance is the circumference. What is the formula of circumference? Circumference is equal to 2 pi r. So if you are considering the particular orbit, we can just generalize the orbit as nth orbit. So for nth orbit, the radius will be Rn. Okay. So I can write the distance as 2 pi Rn divided by V, velocity, that is the speed with which the electron revolves. 2 pi Rn by V. Now from this relation, we get a new relation that time period is directly proportional to radius and inversely proportional to velocity. If the radius increases, that means the distance increases, so obviously time period also increases. If the velocity is greater, it revolves very faster, so time period decreases. So if velocity increases, time period decreases. If radius increases, we know that the circumference increases, that means time period also increases. From here we know that radius is directly proportional to n square by z. We have studied that, and we know that velocity is directly proportional to z by n. So we get a new relation that time period is directly proportional to n cube by z square, which is a very important relation. N cube by z square. Now the next point. Here let's think about the frequency. So frequency is nothing but it is inverse of time period. That means, what does frequency means? See, we consider an orbit. Let us consider an orbit. This is an orbit. We have a central nucleus. Okay. Now let's take this electron. Let's take the unit time. That is, let that unit time be 1 second. If t is equal to 1 second. I wanted to find out the frequency. What do you mean by frequency? See, if the electron starts from here and in 1 second, if it revolves 5 times, if it makes 5 revolutions in 1 second, then frequency means 5. So it is the number of revolutions or number of revolutions it makes in a unit time. See, if I say it takes or it makes 1000 revolutions in 1 second, means what is the frequency? Frequency is equal to 1000. That's all. What do you mean by revolution? Revolution, I have told you, if an electron starts from one point and it reaches the same point, after circumferencing or after circuiting, if it reaches to the same point, then we can call it as the electron has undergone one revolution. Likewise, if in a unit time, how many revolutions has been completed by electron, that number is called as the frequency or frequency of revolution. So number of revolutions per unit time in the nth orbit is equal to velocity by distance. So velocity divided by distance, we know that the circumference, that is 2 pi rn. So here frequency is inversely proportional to 1 by t, or is equal to 1 by time period. This Vn is velocity. This is Vn. Vn is velocity of electron in the nth orbit. Velocity of electron in nth orbit. And this one, frequency, this is nu n. This is how we represent. This is frequency. Don't get confused with both the terms. This is nu n, that is frequency. This is Vn, that is velocity. So frequency is equal to 1 by t. It is inverse of time period. That means if you want to find out the frequency and time period is given, then simply you can find out the frequency by taking the inverse of time period. Okay. Now we know that frequency is directly proportional to z square by n cube. How did I got that? Because we know that time period is directly proportional to n cube by z square. So obviously frequency is equal to 1 by t. That means it will be proportional to z square by n cube. That's how we got this relation. Next, move on to the next one. See, here we have a question. What's the question? Calculate the radius of the first orbit of helium plus and to second excited state of lithium 2 plus. Calculate the radius ratio, right? Radius ratio of the first orbit of helium plus to second excited state of lithium 2 plus. See, here let us first understand what is given. See, here we are given with the first orbit. That means here n is equal to 1 in the case of helium plus. And in the case of lithium 2 plus, they have told that it is the second excited state. Second excited state means it's the third orbit. See, first excited state is the second orbit and second excited state is the third orbit. Okay. So here n is equal to 3. You have to find out the radius ratio. We know that r is directly proportional to n square by z. So in the case of helium, let's calculate the radius of helium. That is n is 1 square. Helium, atomic number of helium is hydrogen helium 2. So it is equal to r1 is equal to, let's give it as r1. r1 equal to 1 by 2. Now take this r2. That is equal to n square. N is 3. So 3 square by atomic number is for lithium, hydrogen, helium, lithium, it is 3. So again we can cancel 1 3 here. So R2 will be equal to 3. So what will be R1 by R2? R1 by R2 is equal to 1 by 2 into 3, that is equal to 1 by 6. So the answer is 1 by 6. Hope this is clear, students. Now let's move on to the next one. Yes. Here, calculate the angular momentum of an electron. You have to calculate the angular momentum. You have to calculate the radius. You have to calculate the circumference and diameter of the third orbit of lithium 2 plus. See, angular momentum mvr is equal to nh by 2 pi. It is given that third orbit is given. So you can just represent or just give the value 3 in the place of n. So you get the value of 3h by 2 pi. Okay. That's all about the angular momentum. Now you have to find out the radius. Radius is equal to, we know the formula, it is equal to 0.529 n square by z. What is the value of n? That is 3, already given here. So 529 into n square, that is 3 square, divided by z, it is lithium. So what is the lithium? Atomic number of lithium is 3. I can cancel this and we get a value of 1.587 Armstrong. That is 0.529 into 3 will be equal to 1.587 Armstrong. So I got the radius. Now circumference. Circumference is equal to circumference is equal to 2 pi r. Circumference of the orbit is 2 pi r. So 2 into, yes Vijay Darade, hi. So it's 2 into 3.14 into 1.587. What will be the value? You can just calculate it. You will get the value as 9.96 Armstrong. Now, one more thing you have to find out, that is the diameter of the orbit. So, we know that diameter, you normally represent diameter like this. So, diameter is equal to 2 times radius. Okay. So, it is equal to 2 into radius is 1.587 Armstrong. That is equal to 3.174 Armstrong. So, hope this is clear, students. It's a very interesting question and it's a simple question. First, they have asked about the angular momentum. So, here we know the equation, it is equal to nh by 2 pi. Then they asked us about the radius of the orbit. So, here we have the equation r is equal to 0.529 into n square by z. N indicates the number of orbit, that's already given as third orbit. So, we substituted 3, and z for lithium, z value, atomic number of lithium is 3. So, we just substituted the value and multiplied, we got the answer as 1.587 Armstrong. Then in the case of circumference, we know the equation of circumference of a circle or an orbit is 2 pi r. Just apply, just substituting the values, you got the answer. Then they finally asked about the diameter. Diameter, we know that diameter is equal to 2 times radius. So, again we got the value here. Okay. Now, the next one. Here, see, the radius of an orbit is given. So, radius is given as 0.85 nanometer. See, I would like to convert this nanometer into Armstrong. See, we know that 1 nanometer is equal to 10 raised to minus 9 meters. Okay. So, I'll write it as 0.85 into 10 raised to minus 9 meters. I can write it as 8.5 into 10 raised to minus 10 meters. Now, we know that 1 Armstrong is equal to 10 raised to minus 10 meter. So, instead of 10 raised to minus 10 meter, I can write it as Armstrong. So, radius is equal to 8.5 Armstrong. 8.5 Armstrong. Okay. Now, what they have asked us to find out? We have to find out the velocity of the electron in the orbit. They have given us the radius. So, we know that in order to find out the velocity, what do you require? We require the value of n, right? So, we have to find out the value of n. That means which orbit it lies. The electron is present in which orbit. That's what you have to find first. So, we know the equation r is equal to 0.529 into n square by z, right? So, the value of r is 8.5 Armstrong. We can substitute that, and n is what you have to find out, n square by z. What do you mean by z? Here it is hydrogen atom, so z will be 1, and I can take this 0.529 to the RHS, so it will be equal to 8.5 divided by 0.529. Okay, so we get the value of n square, that is n square is equal to 16 after dividing 8.5 by 0.529. So, n is equal to 4. Now, we got the number of orbit. Now, what you have to find out? You have to find out the velocity. We know that velocity is equal to 2.18 into 10 raised to 6 z by n. So, substitute the value 2.18 into 10 raised to 6. What is z? Z is 1 for hydrogen and n value is 4. Okay. So, here you get the value as 5.45 into 10 raised to 5 meter per second. Here it was 10 raised to 6. So, I took 10 out and divided by 4. So, I will get it as 5 by 2, that is 2.5, and 2.5 and 2.18 will give you 5.45. So, the final answer will be 5.45 into 10 raised to 5. Yes. Now, let us move on to the next one. See, here, see the question here. multiplication of V and R of an electron in any orbit is. See, we know that multiplication of V and R means it is representing here, right? V and R comes together in the case of angular momentum, and we know that angular momentum is equal to nh by 2 pi. This nh by 2 pi means this is totally what? They are constant. And I can write it as V into R is equal to 1 by m into nh by 2 pi. How? I took the m from LHS to RHS, so it will be 1 by m. Okay. Now let's check the options. It is directly proportional to mass of electron. That is wrong, because from here we got it as it is inversely, VR is inversely proportional to mass of electron. What is option B? Inversely proportional to mass of electron. That's the right answer. It is independent of mass of electron? No, it depends on the mass of electron, since we got the relation that VR is inverse of m, that is VR proportional to 1 by m. So it is inversely proportional to mass of electron. Next question. See students, the ratio of radius of two Bohr orbits of hydrogen atom is 4:1. Then what would be their nomenclature? So this is an interesting question. See, wait a minute. Yeah. Okay. The ratio of radius of two Bohr orbits of hydrogen atom is 4:1. Then what would be their nomenclature? We know that, see, here we know that radius is directly proportional to n square by z. Since it is hydrogen atom, we know that z value is 1. So R1 is proportional to n square, and I am taking another hydrogen atom, that is R2 is proportional to, this is n1 square and this is n2 square. So we are taking the ratio R1 by R2, then we will get a value, the ratio as 4:1. So if this value has to be 4, then what should be the value of n1? n1 should be 2, right? Because 2 square will give you what? 4. So n1 will be equal to 2. And what should be the value of n2, which corresponds to the value 1? If n2 is equal to 1, then n2 square, 1 square will be equal to 1. So that means n2 equal to 1. So n1 equal to 2 corresponds to the which shell? n1 equal to 1 is K shell, n equal to 1 is K shell, n equal to 2 is L shell, n equal to 3 is M shell, n equal to 4 is N shell, n equal to 5 is O shell. So n1 equal to 2 means it is L shell, and n2 equal to 1 is K shell. So the answer will be L and K. Option 2 is the right answer. Let's move on to the next one. Yeah. The angular momentum of an electron, let me check if any of the comments. Yes, till now there are no comments actually. Hope this is clear, students. Yes, so this will be our last problem. Okay, so you can do it by yourself. Please try by yourself. Okay, so angular momentum of an electron is proportional to, we know that angular momentum mvr is equal to nh by 2 pi, and this h by 2 pi is a constant, right? Okay, now we know that mvr, this is a constant, so I can just neglect this. So I can write it as mvr is directly proportional to n. If you remove the constant, then proportionality sign will come. If you remove the proportionality sign, then constant will come. That's how it happens, right? So we know that radius is directly proportional to n square by z, and for an atom z is always fixed. Okay, so that means n will be directly proportional to root r, right? Here n r directly proportional to n square means n will be directly proportional to root r. That I can apply here. So I'll get it as mvr, that is angular momentum, is directly proportional to root r. Yes. So second one is the right answer. So hope students this is clear for you. Okay. If you have any doubt, you can just ask me. I hope there is one more question. Yeah. Let's do this one also. Calculate the ratio of velocity of electron in second excited state. That means, what do you mean by second excited state? N is equal to 3. That means the third orbit. And fourth excited state, that is n equal to 5. So we know that velocity is directly proportional to z by n. So I write it as v1 by v2 is equal to z1 by n1 into n2 by z2. How did I got? Maybe you will be confused if I write like this. So I'll just change it. And I can write it as z1 by n1, that is correspond to v1, and divide by z2 by n2, that corresponds to v2. So I can write it as z1 by n1 into n2 by z2, that is taking the inverse. Okay, what is z1? See, it is hydrogen atom. Both the cases, first one is it is a hydrogen atom, so I can give it as 1. What is n1? n1 means the number of shell, that is the third shell. So here it is 3 into n2. What is n2? n2 is the number of shell of the lithium, that is 5. And what is z2? z2 means the atomic number of lithium, that is 3. So we get the value as v1 by v2 equal to 5 by 9. Okay. Now I hope one more question is pending there. Yeah. So calculate the ratio of time period of electron revolving in the second orbit of hydrogen atom and third orbit of lithium atom. So you have to calculate the time period. We know that time period is directly proportional to n cube by z square, right? So let us calculate the first time period that regards to the second orbit of hydrogen atom. That is, for second orbit you can give it as 2 cube, and for hydrogen atom z is equal to 1, so 1 square, that is equal to 8. Okay, for this second time period is equal to, corresponds to third orbit, that is 3 cube, divided by the atomic number of lithium is 3 square. Okay, so this can be cancelled and we get the value as 3. So you have to find out the ratio, that is T1 by T2, that will be equal to T1 is 8 and T2 is 3, that is 8 by 3. So you got the value as 8 by 3. Okay. So that's it, students. So we have discussed about the Bohr model. We have discussed about the applications of Bohr model, and that is to calculate the radius of an orbit, to calculate the velocity of electron in particular orbit, to calculate the time period, to calculate the frequency. All those things we have discussed, and also we have practiced certain problems related to those applications. Okay, hope this is clear for you, students. If you have any further doubts, you can just comment in the section. Okay, in this video, below the video, once the streaming ends, the comment box will be open for you. You can just ask the question. I'll always check these comments, and if required, I'll clarify your doubts. Or you can also ask your doubts in our Telegram group. Okay, in the Telegram group also you can join, and there you can ask your doubts and your queries. So we'll be happy to clear that. Okay, hope everything is clear for you, students. Now we will meet tomorrow with a new topic, that is regards to the hydrogen spectrum, which is another important topic from this chapter. Okay, students. So until then, bye bye, take care, good night. Thank you.